Hey guys, today let's look at Lintcode problem number 15, permutations. So permutation, this question actually is really classic. It's the algorithm that you have to memorize. So let's see what we need to do in this algorithm. Directly look at this example for a given array. For example, we have 1, 2, 3, and we need to get all its permutations, which is 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1. So our job is to write an algorithm to find all the permutations and how to do this. So the algorithm weapon or secret we're going to use is DFS, which is called depth first search. So before we jump into this algorithm, we need to analyze how we approach this problem by just using a strategy. So I drew a picture. Let me check my picture. You see this picture. For example, this 1, 2, 3, we started with this. To get the permutations of 1, 2, 3, what do we need to do? And first, we need to choose one number from this collection, 1, 2, 3. We can choose different one. We can try choose 1, or choose 2, or choose 3. With different choices, we'll get the different results. If we choose 1, from this collection, then what we got left, we have 2 and 3. So after we choose 1, we still have 2 choices. We can choose 2, then we get a collection of 1 and 2, and we can choose 3, 1 and 3. And same thing for this situation, this situation. And okay, let's look at this part. If we choose 1 and 2, and we only have 3 in the remaining collection, then we can only choose 3. So from this pass, we get one result, which is 1, 2, 3. And same thing from this pass, we get one result, 1, 3, 2. From this pass, we get 2, 1, 3. This pass, 2, 3, 1. And this pass is 3, 1, 2. This pass is 3, 2, 1. So after we try the different passes, then we get different results. And we're going to just, put them all in the list of the list. Then we return. So when approaching this problem, we realize that we always, tries to go from one direction, and we just all the way go deeper. And after this is done, we backtracing. The backtracing means that we just, recover the things what we did. And in this example, for example, here we choose 3, and we just go back. We don't choose 3. Since we don't have anything to try, then we just all the way go back to 1. And then here we started trying 3, then we trying 2. So after we reach to the very end, then we just go back tracing, all the way go back, and we try different approaches because it is always depth first. So we call this kind of a strategy DFS, depth first search. And this is our searching tree. We call it the searching space. All right, so now let's look at our algorithm to see how we do the coding. The right side is our algorithm. So this is our entrance permutation, and we take one parameter, which is the number array. So first part, we definitely have to check the parameter if this parameter is valid. If this parameter is valid, then we just declare the global result. This is empty list. We're going to just put all of our answers into this result. Here, we define a function called DFS. We call this DFS. We pass this numbers array into this function, and we also pass the local variable. I'm going to just detail this part later. So we assume that this DFS function is like a black box. So once we call this, this is gonna calculate all of the answers and append it to the global result. Then we just return this self result. So now let's look at our core, which is this DFS. So obviously DFS is depth first search. It is recursive call. So before we do this, we always have to give a clear definition of this recursive call, our recursive function. So what does this guy do? This guy takes the two parameters. One is number, a list. One is sequence. The sequence is what is this? The sequence is like a 1, 2, 1, and 1, 2, 3. This is used to help the DFS search function to to put the local result in that sequence local variable and pass it down to the deeper level of the function. Pass it down. So still, let's go back to the code. So because this is the DFS, this is a recursive call. So, oh, by the way, definition. I haven't detailed this part. The definition is that for a given number list, we're going to just calculate all of its permutations and we append it to the self.result, this variable. And yeah, and that's it. After we tried everything, and our global variable self.result should be full of answers. All right, so let's continue. Because this is a recursive call, so first thing first, we need to specify the termination condition. We don't want our recursive calls to run forever, so we need to specify when this call is going to end. That is when the input numbers is already empty, then we're going to just end, and we just put our sequence local variable or local answers into this global answers. So SEQ is the local answers. When the nums is empty, SEQ is going to be the local answers. So that's when we append this local result to the global self-data result. And if we still got some numbers in the list, so what do we have to do? We have to try put each number, choose each number, and put it into the local solution. So here we just loop through this numbers list, and we choose it and we push it into the sequence. And we're gonna just pop it out because we already choose this number I, so we got to remove it from this numbers list. Then the next step, we're gonna just continue choosing one from the remaining collection. So this is the recursive call happen place. So here we just call this recursive call to do the same steps. And after we did this, we have to do a backtracking. Backtracking basically just to recover the things what we did to the local variables. What are they? First, we change the numbers, this local variable, because we pop it out one element. So here, when we do a backtracking, we need to insert this thing back, insert to the position I. And also here, because we append this this answer to this local variable, so here we just pop it out, do the backtracking. So that's it. So after we tried everything of the numbers, then we can just get all the answers. So this whole algorithm is going to be finished. So that's it. Let's run it. Takes a little bit of time. Sometimes this web is really slow, but algorithm is good. Gosh, I don't know what happened today. It's still very slow. Come on. Okay, finally it's compiling. So meanwhile, I think we can do some summary. The summary is that this is our entrance. Oh, by the way, one part I'm missing is this. When we pass these numbers into this DFS call, we have to sort this. The reason we sort this because here is for us to remove the duplicates. What is the duplicate? The duplicates, because you know that we have this numbers list, right? So every time we're gonna choose one from the list, but if this current element is the same as what we choose last time, it's not gonna make a difference, make a change, and impact our final results. So we're gonna just continue. So that's how we skip the duplicates locally. So here we have to pass the sorted list, and here we're gonna do the duplicates. Actually, in permutations 1, we're not required to do the duplicates, but we just do it because it's better. Later we have permutations 2, basically the same results. Yeah. All right, so it works. So thanks for watching, and I see you next time. Bye bye.